So the next presentation is about dealing with communication data without content. Here again, as in the previous presentation, I will talk about hidden pattern recognition and here, by the way, it goes wrong way. Sorry. Same Dr. Schwarzer, who is here, who made the major contribution. The lion's portion of this work is due to his work, and also Shmuel Tepler. Okay, so as I said, we are going to look for detection of indicative signs for criminal activities as deviation from routine. Again, very similar to what I discussed earlier, and 10 minutes, isn't it? And discovering criminal activity patterns in geotemporal communication data. So here, the order will be the opposite one. First, anomalies, then hidden patterns. Okay, what we do here, again, I will really have to be brief. We analyze transaction logs for early detection of criminal activities. This may be relevant for banks, credit card companies, police investigation, other forensic applications. So what may be the indicative sign for criminal activities? Maybe sudden increase in number of communications, changes in number of respondents, or any other changes in behavior in suspect population. So the solution is like in the one of the previous cases, in GMM, and the models are built for every suspect person and for every feature, using quite long historical data. I will define it, and deviation from at least one of these feature models will cause an alert. So we distinct between sudden features and cumulative features. Sudden features are those who happen at certain times. So, and also irregularities are attributed to times. So the examples are incoming call start, outgoing SMS, incoming call to a member of the same gang, outgoing SMS to boss. So these events, if they, we want to know at which times they happen. And later on, if they happen at unusual times, this will cause an alert. The cumulative features, we look at how many times this feature was activated at a particular time. And the example of these features are number of calls, number of call receivers. Okay, I don't want to read the slides. You can do it probably better than me, and faster, which is more important. So again, the same idea, GMM, I introduced it already before, so no need to elaborate. The only thing I want to mention here, by the way, it was also relevant there, we, since I remind you, everything is done in real time, or at least online, and therefore CPU and memory must be of great concern, and therefore we invented a procedure of recurrent update of current GMM with new data in order to facilitate CPU and memory saving. And again, as I explained before, outliers become suspects for anomalies, and then for sudden features, as I defined them earlier, it is done every 3 minutes with this sliding window of 10 minutes. And for the cumulative features, it is done every hour with a sliding window of an hour. And then chi-square test deviation from the closest Gaussian, or in absence of the corresponding model, causes alert. Okay, simulation. Again, I remind you, all this was also validated with real data, but of course, for simulation, it's easier to define figures of merit and to define the performances. So we defined gangs with 3-level hierarchical structure: family, gang, and cell. We have 5 family, each one contains 10 gangs, each gang contains 10 cells, each cell contains 10 people. Okay, again, please, you can read it yourself. Each person has a phone, each phone has 3 identifying numbers, and we analyze phone calls and SMS. Now, we simulate routine behavior as described here. Again, I give just the basic principle, and meanwhile you can read the rest of the description. The basic principle is that there are each group is characterized by certain normal routine, and 95% of the communications or events in this group fall into this routine, and 5% are outside of it. And the routines are as written here. Abnormal behavior is that each one of the parameters is changed by X%. Of course, the second bullet is there is a mistake. It should be 95 times 1 minus X and not not X. But okay, the idea is that each parameter is changed by X%, and the results are here. So we can see that, of course, when the change is very small, 10 or 20%, the recognition is quite poor. But as the anomaly becomes more prominent, like starting from 30% and more, then, of course, it is very nicely detected in terms of both accuracy, precision, and recall. And when it is 50%, it is already above. If the change is 50% or more, then the results are above 90%. The last topic is, what did I do? Discovering criminal activity patterns in geotemporal data. I have 4 minutes. So the problem definition is the following. We have organized, we assume that organized crime activities are characterized by long spatial and temporal patterns. And here is just an example. Bosses meet one another at a certain place or in certain places. Then some logistic preparations take place. Technical preparations take place. And everything takes place in different locations. Then shipping of ammunition or other resources takes place, and the intended criminal activity is performed. So this is hidden, but partially it may be disclosed by communication activities of the criminals. Besides, we, of course, know the location of their, let's say, cellular phones. So the assumptions are that the pattern is a sequence of states, each characterized with beginning in the past relative to intended activities, duration, and distance from the intended activity. And, of course, each state is mapped to communication activity pattern in a feature space. Now, the solution is supervised learning. Again, I will just give you the basic idea. The basic idea that we build spatial and temporal, say, rings or rectangular rings, so to say, around each potential suspected activities. We do it both for positives and for negatives. And we defined a multitude of features. This is just illustration. These are examples of features. In practice, there are hundreds of features that we are using. Features may be network features or geographical features or relative features. Now, then we categorize the features into three categories, large, medium, and small. Yesterday, I heard the word bucket instead of category, which I liked very much. And because these are more suitable for interpretation. And then we perform both for positives and for negatives discrimination by using CMAM procedure. Here I just want to mention one thing. It is commonly known that CMAM has a local greedy fashion. Namely, it provides optimal solution every step based on works performed by people, most of whom are present in this room right now, Professors Muchnik and Mirkin and Dr. Schwarzer, and Arkady Volosh, who hopefully will join us later. It was shown here that the resulting sequence of successfully chosen features optimizes the global minimax criterion of feature selection quality, which of course is maybe also of interest here, because I'm talking about only practical things, but here was at least some also scientific contribution. And then we perform clustering of positives and negatives separately, and based on this, we succeed to generate patterns. Again, I apologize for squeezing it, but I suspected it would be too long. Just the last thing, the nice thing about it is that it can be also formulated in such terms that it can be interpreted in human language, like increasing numbers of calls between bosses, 5 hours before intended activities. 9 kilometers from it means that they're entering to the will lead to entering to the ammunition storage 3 hours before it, and then will lead to the intended activity. Here we have, again, the definition of simulation and simulation results, which unfortunately I can't show you. Just the last thing, when we simulate normal activity, namely, when the suspected guys behave normally, then of course the results are trivial. 50% is recognized as intended activity, and 50% is not. But when actually the criminal activity is simulated, then the results are really very good. Here we can see that all the actual intended activity, criminal activities were detected. None was missed, and none was wrongly attributed, and 2 were missed. Only 2 minutes late, but I hope I didn't tire you too much. And finally, the credit, the references, and thank you very much.